Hello dear students, today we are going to discuss experiment to find resistance of a given standard wire using meter scale. This is our whole setup which composed of 1 meter scale, this whole meter scale, which have one very thin wire over it, over which we will move the jockey. This is a slider which we will move from one end to another. So first one is meter scale, this one is our meter scale. Second one is resistance box of range 1000 ohms, whose resistance will be the value we unplug. If I have unplugged 2 ohm, it offers 2 ohm resistance. If I unplug 2 ohm, it will offer 2 ohm. If I unplug 5 ohm, now it will be offering 7 ohm resistance. Next one is galvanometer. Galvanometer is the device which detects presence of current. If there is current, this zero needle will goes to this side or to this side. If current is not present, it will be at zero, right, which is at present right now. This one is the battery eliminator. This is source of potential, source of current. It converts given AC supply to DC supply. So these are the two output units, these are two input units, but we have to need it for DC supply, so we will connect over here. And we can change its voltage from 0 to 12 volt. At present we will operate it at 4 volt. Okay. So how we have to assemble this circuit? How we have to assemble this circuit? So we will assemble the circuit as per this circuit diagram. The principle of this experiment is Wheatstone bridge, whose theory we will discuss in the class, in the theory class. So in experiment, we will have to set the value of PQRS in such a way that galvanometer shows zero deflection. Once galvanometer shows zero deflection, it will get a condition of P by Q is R by S. So in experiment, how we will guess that this Wheatstone bridge is balanced? Once galvanometer shows zero deflection, means Wheatstone bridge is balanced. In theory, we have 4 resistance. To break this into the simpler one, we use meter scale, because once we slide the jockey over this meter scale, at certain value it will show zero deflection, and resistance is proportional to length. So this P or Q gets converted into L or 100 minus L. Like in the diagram you can see, if jockey is balanced at B point whose length is L, so P will be L and Q will be 100 minus L. If wire have uniform area of cross section, S whose resistance we have to find this wire, and R what the value we are unplugging from the resistance box. So we will set the circuit diagram as per this circuit diagram. Now we can proceed this experiment. But before proceeding, we have to verify that whether all the components are properly working or not. To verify that, we have one device called multimeter. Multimeter means it can measure voltage. This is a range of 200 millivolt, 2000 millivolt, 20 or 200. This is for measuring the resistance varying from 2000 kilo ohms to 200 ohms. This is for measuring the current from 200 milliamperes to 2000 microamperes. This is for square wave, this is for AC voltage, but we are going to conduct experiments for DC. So let's see how this multimeter works, then we will come back to our main experiment. To measure current, we have to connect positive end to A side, A ammeter upper side. So we will connect it here. and common ground with over here. If I want to measure the current, we will rotate it to, if I am setting it here, it can measure current up to 200 milliampere. If I set it here, it can measure current up to 200 milliampere. So how we will connect this? Let's see. I have connected positive end with this positive and negative to this side. See how much current it is showing? It is showing current of 65.566 milliampere. So this much current is we are getting from this battery eliminator to the circuit. Where I have set it the value to measure the current, I have connected positive end with the ammeter and negative with the ground and connected with the source supply, so that we can get whether we are getting sufficient current or not. Now I am shifting this to check the range of voltage. So where is the voltage? Voltage is labeled over here. So we will shift it to voltage side, that is up to 20 volt. Now I will connect it to positive end. I will connect with positive end of the DC source, negative to the negative. Now I will turn on the battery eliminator. It is not showing this value. No, it is not showing. Why it is not showing? Because to measure the voltage, our positive terminal should be at the V point. So we have to disconnect this from ammeter to side voltmeter. Now if we measure, it will offer us the given value. Let's see. I have connected, but it is showing 1. 1 means it is above its range. So we have to shift it to next side. See, it is showing 3.9, 3.93. Wait, connection should be tight. Yes, it is 3.98, and in the battery limit is showing 4 volt. So obviously some resistance should be there, so it will lose some of the voltage. So that's why it is showing some less value. So in this way we have checked that battery eliminator is supplying us voltage of 3.98 and current of 65 or 66 milliamperes. Now we will check whether galvanometer is operational or not. So galvanometer detects presence of current. Let's see. It is showing any value? No. We have turned off the supply. So how we'll check galvanometer is working or not? We will check its resistance. See, when it is not at, it is at voltage side, it is not showing any deflection. But when I am going to check its resistance, of certain range, its needle gets deflected and it is offering resistance of 102 ohm, means galvanometer is also working. So our multimeter is telling us whether the components connected in the circuit are working or not. At present we have checked battery eliminator, how much current it is supplying, how much voltage it is supplying. Then we have checked whether galvanometer is working or not by checking its resistance. At its range of resistance of 2000 ohms, it is showing deflection also and giving its resistance. So it means it is working. Now we can use the apparatus. So during the experiment, if you found it is working, it is not showing the absolute result, means something is there in the circuit which we have to check. Either the wires are not properly connecting, or some of the component is not working, or maybe it is showing some heating effect. And this multimeter helps us to check whether the component is working or not. At present I have set it to 0 volt, set it to off mode. Now I have connected the circuit. Now it's time to check whether circuit is properly connected or not. What we will do, we will slide this jockey to one end. We will place this jockey at one end. I have placing this at this point. See galvanometer is showing deflection to right side. I have connected to left side and it is showing deflection to right side. Now I am picking this jockey and placing it over the right side. See, galvanometer is showing deflection on the left side. If this thing is confirmed, it shows that circuit is ready to use. There is no such query that circuit is connected properly or not. And it also indicates that balance point should come between these two endpoints. If deflection is on the right side only, either on checking the left or from the right, or it is on only one side, either left or either right, it means our balance point will not come during that setup. So we have to either change the voltage or certain setup so that it gives deflection on the either side when we connect it from one end. Like in this case, it is showing deflection to right side. When I am setting it over here, it is showing deflection to left side. So now we can proceed the experiment. What we have to do, we have to change the resistance. This is our observation table. We have to pick the resistance from resistance box, check the balance point B where it comes over the slider as labeled over here, where it is showing. If it is coming at 30, it will be 30, and 100 minus L will be 30. Resistance की वैल्यू B पॉइंट कहाँ पर बैलेंस हो रहा है, लेंथ, what will be the length, then we will see the length 100 minus L, then we put the value of R and this, we will get the resistance 1. Let's do one reading. So I am plugging a resistance of 2 ohm. I have unplugged the value of 2 ohm. So resistance box is offering 2 ohm. Now I am start sliding the jockey. Now see the galvanometer on the same time. I am changing its value. But it is not deflecting. It is at right side only. I am changing its value. I am altering, shifting the jockey. No deflection is there. Now it started deflecting, means balance point is about to come. Wait a while, it is no, it is about to come. Now we have to move slowly. We have to move it slowly. Yes, it is about to come. Yes, it has arrived. So let it to stable there. Let it to stable there. Yes, it is almost stable. Due to heating effect, maybe it is deflecting, but otherwise it is stabilizing at, yes, this point. How much is the reading over this point? It is 82.5. So our L will be 82.5. Resistance from the resistance box is 2 ohm. B is 82.5. L will be 82.5. 100 minus L will be 17.5. Put the values and get the respective resistance. Now I am changing this resistance to 4 ohm. Now I will again slide the jockey from one end to another, but have a look over the galvanometer at the same time. Now I am changing. It is arriving near about this point. Let's check again. Now it is about to balance. Now it's balanced again. It is balancing at 82.4. At 82.4 it is 82.4. It is at stabilized. It should be stable. Not stable. No, it's stable. Yes, it is 82.7 at 4 ohm. At resistance of 4 ohm, it is 82.7. It will be 82.7. 100 minus L will be 17.3, and respectively you can measure the value. So in this way we have to take 6 readings by changing the resistance from the resistance box. I hope you are able to understand this experiment. After doing this, we have to find the mean value of resistance of this wire, which we are measuring using meter bridge. If you want to find the resistivity, directly use the relation rho is RA by L. R we have found here. R is we have notating with S. Area is pi d square by 4 into L. L is length of the wire. D is thickness of this wire, which we measure using screw gauge, and we will get the resistivity also. In the same manner we can do measurement of the other different wires also. I hope you are able to understand this experiment.